Had a wonderful program, wonderful day, and I'm sure you've got lots of questions. Hopefully not one of the embarrassing ones I was about to ask this afternoon, but won't, because I didn't want to embarrass him. Who's going to be first? Gentleman at the back. Oh, if you'd like to stand up, please, it'll make it, and also there's a microphone that's floating to you.
Right. Thank you. Yeah, can you hear me all right? Yeah, it's a question for Phil about cuckoos. The birds that you tagged, were they all male? Did you get any tags on females? And is there any difference in behaviour?
We would love to have tagged females, but they're quite a bit smaller than males. So the tags are 5 grams, males weigh about 110 grams, and we don't really want to put anything on that's more than 3 or 4% of body weight. So if we put them on females, it would have exceeded that limit, so we couldn't do females. But saying that, in Belarus, because we've got a project, tracking project there, the cuckoos seem to be about 20 or 30% bigger. So we have tags for females, and there doesn't seem to be much difference from those birds. But saying that, the satellite tag company are promising us 2-gram tags next year. So we'll hopefully be able to tag females and hopefully some juveniles as well if we can raise the money for it.
No, that was the question I was going to ask.
Same question.
Oh, another one right at the back. You'll get lots of exercise like this.
Thank you. Yeah, to Phil again, just sticking with the cuckoo theme. The places where they're overwintering, the little slide you showed was a sort of reservoir surrounded by trees, and it was a bit like the Scottish Highlands. Has there been a lot of habitat change in that area, or is that its natural state, or has it been denuded and things like that?
No, that's its natural state. And there's a very low density of people there. So we don't think there's been much habitat change there. But there has been a lot more habitat change in West Africa. So the Guinea savannas in which they're passing through in spring have really been transformed by agriculture, grazing, collection of wood for building and for fuel and so on. So yeah, the winter grounds may not have changed, but the staging areas certainly have.
All right, okay, thank
Someone's coming.
Fish one.
If you could stand up, that would be helpful, please.
A fish one. I mean, you talked about 3 or 4 species. I mean, have you any idea at all how widespread the various movements are with other species, or is it purely? I mean, you had quite a few moving up through the Channel, through the Dover Strait to the North Sea, for example. I mean, how widespread is that? Does anybody know?
Do you mean by species, different species, or?
Yes.
We've only worked probably on about half a dozen species. What I didn't talk about is, well, we know that salmon are migratory. We've done work on thornback rays, and they seem to be migratory as well. But a lot of species aren't particularly migratory. And we've just started work on sea bass as well, which are migratory. But it's mostly the bigger predatory species.
Could I ask a question, a fish question? These eels are going up and down several hundred meters. Are they actively swimming up, or are they just sinking like a shark, or how are they controlling their, I assume they have swim bladders, do they?
They do have a swim bladder. One of the potential issues is there's a parasite of the swim bladder, which is a native of Japan, but got introduced into Europe in the 1980s. And there is the potential that it could be the parasite damaging the swim bladder that is affecting the ability of some eels to vertically migrate. And obviously that we now know that is a much more important part of their biology when they're in the open sea. But yes, they're moving over several hundreds of meters on a daily basis. Huge changes in pressure, huge changes in temperature, which must be having some sort of physiological effect, but we don't really understand what it is. But presumably it's worthwhile, because they wouldn't do it if it didn't have some value to their life history.
So you think that predation is the principal cause?
I think so, because, I mean, the other thing you might expect is that they're following food, but the received wisdom is that eels don't feed when they're at sea. And if you dissect a silver eel as it's emigrating out to the sea, you discover their stomachs have almost completely atrophied. They don't lose their stomach entirely because they have to drink. All marine fish have to drink because they're losing water across their gills. So they retain a vestigial gut so they can carry on drinking, but they don't feed. So they're not following prey, so they're presumably avoiding predators. But the rates of vertical movement that they make couldn't be achieved simply by adjusting their buoyancy, because they're physicalists. They have a closed swim bladder, so they wouldn't be able to secrete gas into and out of the swim bladder fast enough. So there must be active swimming movements. And we have some data from eels where we've been gathering depth data on a minute-by-minute basis, which allows us to actually see the swimming bouts, and they do seem to be swimming.
Ever thought of putting cameras on them?
Yes, we don't quite yet have a tag small enough to take a compass that can go in an eel, but it'll happen before long, I'm sure.
Thank you.
I've heard a lot about the way that various tags have reduced in size. I've read a lot about supermarkets wanting to use passive radio frequency identification tags. So there's no battery inside, it's just energized by radio waves from the detector. And these presumably are cheap enough for supermarkets just to stick on the products and monitor as they go into the baskets. So if they're very small and very cheap, possibly they could be used for insects. Do you know of anyone who's done any work on anything small enough? I deal with insects that are a lot smaller than the stag beetles that Colin does, but does anybody know anything about that sort of approach?
Yeah, there are some studies which have placed them on bees to clock insects going in and out of hive entrances. The problem is that because it's a passive tag, it has to be induced by a coil. So the tag goes through an induction coil that activates the tag and it then pings off its RFID, which is picked up by an antennae. They're also used on bats, so you can have, they're called PIT tags, or passive integrated transponder. It's an RFID tag. It's placed under the skin in the back of a bat, and then because bats also go through small holes, you have an induction loop around the hole, and it'll clock them going in and clock them going out. But because it has to induce the signal to be pinged off, you can't do it at any great distance. It has to move close to an induction loop. Yeah, so I think they have been used in fisheries as well, I think, where, so you can funnel the fish into a small passage, again, have an induction loop, and as they go through it pings. Did you want to add anything to that?
They're not much use for marine fish because the radio waves don't go through seawater, but I have colleagues at Lowestoft who use the process specifically for looking at salmon and trout migration in rivers, and they put the antennae right across the riverbed, and then as the smolts go across it, they're detected.
When I went to see Dave Chesmore about following the larvae, because they live underground, we were talking about how it could be done, and he mentioned RFID tags, and he got some and a reader, which he gave me and I brought home and tried. But you need the insect larva or the insect itself to be that distance away from the reader. So if your larvae is moving down, you've lost it.
The same things that go in your pets, when you microchip pets, the same things.
Any other questions? Yes.
One for Tom. Until we get cheap DNA analysis of the creatures, we're relying on the verification of experts for many groups. New technology, will this help with the next generation of experts, or perhaps even hinder it by making out it's so simple that all you need to do is look at a picture?
I think will never be at a point where the expert is made redundant. Things like DNA analyses are incredibly complex, and the results always need to be interpreted by an expert who understands the organisms that are being tested. They always need to be validated against expertly ID'd specimens. So I don't think we'll ever move away from requiring experts. Hopefully what we'll see is technologies, meaning that we can exploit isn't the right term, but we can utilize experts more efficiently by making the data we need verified or that needs the expert gaze. We can make it more readily accessible to them.
Go on, there must be some more questions out there. I didn't notice too many people sleeping this morning.
This is a fish question. I was wondering what stage we're at with a lot of these fisheries of, you mentioned the molecular genetics of the flatfish that you were showing, and linking where they were caught maybe back to where they were born. I mean, where's that sort of at with other fish in the North Atlantic, in the North Sea?
So I'm not quite sure I understand your question.
What you talked in your talk, you showed an example. I think what flatfish was it you talked about again? Plaice. Yes. Of using molecular genetics to characterize breeding stocks. I was wondering how much that's been used on other fish species in the North Sea and North Atlantic area.
Okay, and we didn't use molecular genetics.
I'm wondering where.
What I was showing there was that where we used to think they segregated out to different spawning grounds and they always returned to the same spawning ground, that would lead you to believe you would get genetic separation between stocks. But what we've actually found is that they tend to intermingle on their spawning grounds and separate out to different feeding grounds. And that would explain why those people who have tried to use molecular genetics haven't found any particular genetic structure in the plaice population. And that goes for a number of species where we might, from what we know about their migratory history, we might have expected to find genetic differentiation, but in fact there quite often isn't any. In fact, even plaice, there isn't any genetic differentiation for plaice all around the UK, but nobody who's ever been tagging plaice would ever expect plaice from the Irish Sea to move around into the North Sea, but there's still no genetic differentiation. And the trouble is you only need a very small transfer of individuals from one stock to another to get genetic homogeneity. And so 1 or 2% translation of individuals from one stock to another can get rid of any genetic difference, but of course it doesn't make any difference in terms of fisheries because that small number of individuals wouldn't make any difference to the abundance of the stock, but it just removes all the genetic differentiation. So generally speaking, apart from a few isolated examples, molecular genetics isn't telling us a huge amount about population structure, which is why we need to look at movements rather than genetics.
Just a question for Dr. Metcalfe, again, related to fish, obviously. I was wondering how much the CFAS is involved, the marine conservation zone process. I don't know if you're aware of that, how much you know about it yourself, but just a general query, really, as to how much CFAS is involved.
I'm personally not involved. CFAS is involved in giving advice on some aspects of how and why the zones were chosen, but I don't really know an awful lot about it. I mean, we haven't been a central part of that work.
Oh, can I ask another question here? Well, I've been interested in cameras for a long time, but is there a good website where we can see comparisons between all the specifications for the different models, you know, what they do, whether they work in the dark by flash or by infrared, for instance?
Yeah. So there's a great website based in the States called TrailCam Pro, which does a lot of testing of different models, publishes the results of those tests, gives you the prices and so on. And So that's always my first stop when I want to hear about a new model or something, and usually they've already done a load of trials. So they do these experiments where they look at the sensitivity, how the sensors work. Gives you a lot of great information. So if you're looking to try and figure out, if you're wanting to buy a camera and you want to figure out what the most cost-effective one is, so the best one within your budget, and that's a good place to stop first off.
Right, that's Trail Cam Pro.
Trail Cam Pro, that's it, .com. Yeah.
Thank you.
Can I just add very briefly to that? I had a slide about hacking stuff. You can, if you don't want a good quality camera, and you might get stressed out in the evenings trying to get this thing to work, but you can take, I've taken a cheap £30 digital camera I bought off eBay. You take the infrared sensor, a filter off the sensor, and you can download some free software if it's a Canon camera off the internet, which will turn it into a trail cam. I'm sure the photos are nowhere near the same quality, but quite a fun project and quite cheap to do. Good for kids.
I have a question at the back here. Hi, I'd just like to know what the society is doing to capture this enthusiasm, citizen science, and all the technology that the youngsters that may not be in this room today are using to identify things. How can we capture them as the recorders for the future?
Who is that question directed to? All of us. Well, certainly the technology is amazing that's out there, and it depends on all of us, doesn't it, to get out there and become enthusiastic about something in our back gardens or in the neighbourhood wood or whatever. And it does take a few pounds every so often as well. But there are grants out there. As Joan said a little while ago, this society does provide grants for survey work. And so any members or non-members who become members can take part and utilise some of those funds.
I would like to encourage all the experts out there to share their knowledge, particularly with younger people. And I know for younger people, harnessing this technology is really exciting. But I think we do need the experts to get out there and talk to people as well, because we don't want a generation who grow up thinking that they can get something identified just by putting a picture on iSpot. So that's an appeal to the experts, please.
If I could just add something to that. Used to be called public participation and now citizen science. Public participation has been going on for a long time. I started when I was doing my first stag beetle work on stag beetle surveys. And first of all, it started in my own village in Bentley. Everybody knows me in the village. Started getting records from them because there are stag beetles in our village. And then it spread from there via the Suffolk Naturalist Society. I put information in their newsletter, got more records in from people around Suffolk. And then the People's Trust for Endangered Species, who funded all my equipment, apart from the radio tracking equipment, put it out to the general public across the country so that we got hundreds, if not thousands of people involved, particularly with looking at stag beetles that had been killed on roads. And there was 8 years' worth of roadkill survey conducted, not just by me, but by many other people in the UK.
I know I was really pleased how many schools took part in the Norfolk Bat survey. I think it was about 20 schools took part, and teachers found interesting ways of exploring the kind of feedback they got back. So there was a maths teacher who plotted out the distribution of common pipistrelle leaving their school grounds, and I think there's kind of more opportunities there. I didn't kind of push it with schools, but there are quite a few who actually took part, which was quite encouraging.
Just to say that anybody here, whether you're a member or whether you're not a member, if you've got an idea that the SNS might adopt, then just go onto the website sns.org.uk. You can download a bursary form, you can put your proposals on there, and then they'll be considered at council.
I had a question about camera trapping. Presumably you're producing hours of footage to get an idea of the abundance of these species, your wonderful graphs showing how active they are during the day. How many hours do you spend watching camera footage to log this data?
I guess I'm kind of lucky in that I tend to work with students who do a lot of that for me. So I end up with a nice, clean data set. But no, the point's very well made that you can end up with way more information than you can easily deal with. There's a huge amount of time involved in that. So for example, a colleague of mine is setting up a survey in the Netherlands, and for logistical reasons, they're just going to leave the cameras out permanently, pretty much. But they're not even going to use half of those data. They know that they only have capacity to process about 3 months a year of the data that's coming in, and they're just going to archive the rest for possible later use. So yeah, that is a major constraint in the use of the data to some degree. As we go forward, there are image processing tools which are coming online. There are people working on initially pattern recognition, just so that you can separate something from nothing. People are trying to work towards species recognition, but that'll take a bit more time.
I can see you could do it with badgers, where you've got basically a barcode, but
right. So, yeah.
For some species it's going to be a lot harder.
Yeah, absolutely. So we're a ways off really having those tools working. There's a citizen science link here, and one of the Zooniverse projects that's come online recently comes from the Serengeti, where they have a very intensive camera trapping program, and they're getting people to pre-process all their images, so you can look at those images online. ZSL has a similar app, Instant Wild, which you can go and look at the images coming in from various places all over the world and help to kind of pre-process for identification. So ways and means of trying to get around that bottleneck, but it is an issue for sure.
Actually, I'd like to say at lunchtime, when I was talking with Marcus, working on the Tiger project, students are used to put up the cameras because they are seen to be expendable. It was something like that, anyway.
You got the gist. Hi, I've just got a quick question for Stuart. Have you come up with any innovative ways of storing all this data that you've collected through the Bat Survey project? Because at CFAS we have problems, with all the data we collect. The sheer volume.
I think the biggest challenge was actually thinking of trying to find a clever way of getting it back from people, and I think I've failed to find a clever way of getting it back from people easily, and ended up using Post, which didn't seem terribly clever. But
I mean, presumably over time you're going to come up with quite a lot of data from the project.
Yeah, so I've got external hard drive terabyte of, getting on for a terabyte of data now from last year, backed up in a couple of places. But just trying to move that around is it's massive, and it's continuing the project. It's going to build up. I'll think about that in the future.
Good luck with that one.
Cheers.
Can I just add something about schools very quickly, if I may? I go into schools quite a lot with stag beetles because I'm asked to. There now is a schools project on the website. If you go to either the Suffolk Biodiversity Partnership website or the People's Trust for Endangered Species website at ptes.org, you'll find the school project on there.
At the back. Yeah.
Yes, hello. Two really, but one very quick one to Dr. Newson. What is the range and spread of the automated acoustic?
The actual detector range?
Yeah.
It's really variable depending on species, which means you can't compare the number of bat passes between species. Within species, it's fine. So things like brown long-eared, they have to almost hit the detector to actually trigger it because they're so quiet, which is a bit annoying because quite often you have the person taking part saying, I've got brown long-eared in my house, and they put a detector in their garden, don't detect it. Things like nocturnal up to 40, 50 meters, there's a really big difference in the detection probability of detecting a bat, depending on species.
Okay, thank you. Yeah, and if I could, you can indulge me just one more. I was a little bit confused. This is Dr. Atkinson. It would appear that now the drought in the Sahel is not so often, I believe you said. And the sedge-warbler, San Martin, white-throat, chiffchaff are all recovering. And you said that that northward spread of rain was quite regular, northwestward spread. Have you any ideas why? I believe the graph showed that nightingale, wood warbler, spotted flycatcher, and the fourth one that I missed, they were going down, they were reducing.
Yeah, so the Sahelian rainfall seems to follow a 40-year cycle. So back in the 70s, we were right at the bottom of that. We're now reaching the peak, or just past the peak of rainfall in the Sahel. So things wintering in the Sahel are doing okay. The species that are declining, which I mentioned, and you just mentioned, they actually winter in the Guinea savannas and in the wetter areas in West Africa. So they're not just there in spring, which the cuckoos, the swifts, the nightjars are just there for a few weeks in spring. And what we think may well be happening is that habitat change in West Africa is affecting those species which are declining very rapidly now. Habitat change in that part of Africa has been really very, very rapid indeed. And those species which winter there may well be worse affected than the other species like cuckoos, which only spend a few weeks in that area. That's still work in progress though. So.
Caused by man, I presume?
Yes.
Primarily.
Yeah. Yeah.
A small mammal, a mammal question. What's the utility of the your camera trapping technique at the moment for very small mammals? A lot of the ones you showed were sort of medium, large ones.
Yeah, so camera traps have been kind of developed with larger mammals in mind, really, but there's no reason that they couldn't be, that the principles of camera trapping couldn't be applied to smaller mammals. And people have been experimenting with that, and you do pick up smaller mammals, but you need to deploy them in quite a different way. So if you set them for larger mammals, you're not going to see many small mammals. You do sometimes, but it's going to be more hit and miss. So one thing that people are attempting to do is to, rather than set them on a tree looking out vertically, try and put them a bit more looking down from above, or looking down at an angle, so that you're seeing a patch of ground and potentially baiting that ground to bring the small mammals in. I think particularly in Australia, people have been using that with some success. There's a few interesting papers now where that's come up with some useful results. And I think it's a bit early to say where that, what we can really do with that. But I think potentially it is a useful method alongside live trapping that could expand what we can do. So particularly the fact that it's less invasive. You don't actually have to capture the animals. You can set up a survey more quickly and easily that way potentially. So yeah, there's potential, I think.
Anybody else with any questions, burning or otherwise?
Am I allowed to ask one?
Yes.
I wanted to ask Phil. I wasn't quite clear. So you started out with this contrast between the upland, what's happening with upland cuckoos and lowland cuckoos, essentially western, southeastern. I wondered if you're getting any insights as to what is driving those differences.
Yes, but we don't know the reasons for it. So when I showed those pictures of mortality, what I should have said but didn't say was this southwestern strategy that goes through West Africa and travelling 3,000 kilometres further to get to Congo is only shown by English cuckoos, southern English cuckoos. And they seem to have two strategies, whereas the Welsh and Scottish cuckoos all go down through Italy. So there seems to be a higher mortality in the English population because they do this route that we didn't suspect. Why we get these two different routes, I don't know. It could well be that maybe after the last ice age we had two different invasions by cuckoos. So the perhaps Iberian and French cuckoos came up through France to southern England, and Scandinavian cuckoos came over westwards into sort of northern England, Scotland and Wales. And certainly the Scottish birds behave exactly like Scandinavian cuckoos. So the timings of their departures and stopovers are very similar to Scandinavian cuckoos. So I suspect a lot of it is down to the routes they take. And it just so happens that the English population is suffering higher mortality because of they take this riskier route. But why they do that, I don't know.
Could I ask, how do they navigate?
Good question.
Because as I understand it, these are birds that leave this country after they've fledged from whatever bird they're parasitized. So what actually directs the direction that they go? And a follow-up to that is, can you see any possibility of programming a radio or something that you could stick on them to get them to fly further east rather than west?
So I was talking to Julian about this earlier, and he was saying it's very difficult to tag naive fish because the ones that you tag are successful. So it's the same with our cuckoos. We've not been tagging juveniles, we've been tagging returning adults. So they've already done the return journey once or more than once and survived. So we don't really know that much about navigation. And I know the Swedes attach some radio or satellite transmitters to fledgling cuckoos. I think they've done it a couple of times now. And the mortality was very high. I don't know if people have seen juvenile cuckoos, but those are the big fat birds. They sit in the bottom of bushes and they squawk. They're very, very attractive to predators. And I think the furthest one got a few hundred kilometers before it was predated. So we haven't learnt much about how juvenile cuckoos navigate, but that's a really fascinating question. There's no cultural inheritance, so they don't know their parents, they don't know which way to go. So hopefully when we get these 2-gram tags in the next year or so, we might be able to attach some to juvenile cuckoos and see what happens. But the adults seem to use these rule of thumbs. They go back to the same stopover sites. If they don't like it, they go back to the previous stopover site, and that's the strategy that they seem to use. But how they actually develop that strategy to begin with, we don't know.
A bit more research.
Yeah, I think it'd be fascinating if we can get juvenile cuckoos tagged.
The mortality you've mentioned has been in Africa, but have you noticed any impact of hunting in Europe on bird populations?
No, we tend to lose very few in Europe. We've not lost any birds during the breeding season, apart from one in Wales when there were incredible floods 2 years ago. Most of the mortality seems to be in spring seems to be on the northward migration on the north side of the Sahara and in southern Europe. In autumn, it tends to be on the Sahara crossing itself. So we've not lost many birds in Europe at all. Certainly through Italy, I don't think we've lost any. We've lost a few in France and one or two in Spain. That was 2 years ago when there were big droughts in Spain in autumn. We think food supply was a problem then. We have had birds pass over Malta. Yeah, and the Maltese have been sort of have actually been contacting us, and we've been issuing press releases saying, will this cuckoo make it or will it get shot in Malta? But they tend to take their long hops from northern Italy and then cross over the Sahara from there. So it's quite unlikely that they will drop into North Africa or some of the Mediterranean islands.
Just a general point, obviously when sonar came along it helped us detect submarines that were hidden, vessels that were hidden. I wonder if the panel wanted to make a sort of general comment on what sort of techniques might be used if we but had the technology, you know, imaginings in your minds about how you might like to detect things and how that might work.
Everyone's looking at the roof.
Just a kind of bit tangential, really, but a colleague who I work with the camera trapping analyses on quite closely was sitting on an aeroplane and got chatting to the guy next to him recently, and turned out to be an ex-military, American ex-military guy, and he said, oh yeah, we used to drop these cameras in the forest and just get all the pictures sent back to us so we could, you know, have surveillance of what was going on with the enemy in the forest. And I'm sure you got much better technology than that these days, and you know, that was decades ago. And you know, my colleague Chris said, actually, no, we're not there with wildlife. So I think, you know, potentially, just as a, you know, very general response to your general answer, military technology is potentially the place to look for the next big thing. The trick, of course, is making that affordable. So that's where we need to be looking.
Certainly in the bird tracking department, where we need very lightweight tags, battery technology is really important, because the electronics, a sort of accelerometer or a GPS chip, are absolutely tiny. They're sort of 5 millimeters square and weigh very little. It's the battery and the recharging of the battery which is the limiting factor in terms of size and weight. And I think in the next 10 to 15 years, well, in the previous 10 to 15 years, battery technology hasn't changed that much, but there are some step changes coming up which may well revolutionize how we power some of these devices.
There was a question a little earlier which mentioned DNA, so I thought I might come back to that. The idea of taking your cup and taking a scoop out of a river and then running it through a machine to tell you every organism that's present is a bit sci-fi, but it's getting closer and closer. We've seen really, really big advances in DNA analysis over the last 10, 15 years, so I think that would be something to watch as well for the future, that sort of thing. Environmental genetics. Yeah.
Well, are there any last questions? Because of the difficulty of travelling today, I don't want to hold you up any longer than the due time for finishing. But if there are any other questions that are... Yes.
Hi, have you got any advice to give people who are wanting to become biologists, ecologists, the next doctors in the biology nature field? Do it.
It's great.
Even when you're older, I'm doing a PhD now.
I would just say keep doing it, keep getting involved. You know, if you're a member of the society, then that's a good start. Get involved in all the opportunities that presents. You know, get stuck into doing the field work, looking at the data. You know, just ask around and take every opportunity to do that, I would say, and that'll put you in a good position to pick up opportunities to move forward.
The Field Studies Council, I don't know if you've heard of them, run courses all around the country. There's Flatford Mill in Suffolk, not many miles away. They're based in various counties around Britain, and they run all kinds of natural history courses, even art courses, I believe. And so that's a good organisation to get involved with, because the courses are run by often the national expert.
I've just got one comment to make. We've seen ways of looking very closely and very hard at individual problems, trying to understand how different animals behave, getting better and better at that understanding. But there's not much point doing any of that if those animals disappear. And I think conservation, I hope everybody in their work is thinking about conserving the animals that they're looking at, or before we know it, they'll be gone.
Well, I think we ought to draw this to a close now. I think we've had some marvellous contributions from our speakers, and I'd like to say a special thank you to all of those.